In section 7.3, the double angle, half angle, and product sum formulas, we're only going to focus on the double angle identities. The other ones don't affect us enough in the calculus class, but this one does. So if I want to find the sine of twice an angle, so the sine of 2 theta, I can find that by multiplying 2 times the sine of theta times the cosine of theta. I want you to notice that the cosine of 2 theta has 3 separate formulas, and that kind of means that you could use any of those 3 formulas in order to simplify. I crossed off the first one though. Cosine squared theta minus sine squared theta is one that I have never actually used, so if I've never used it, you're not going to use it. The other 2 are ones we probably will use, so 2 times the cosine squared of theta minus 1, or 1 minus 2 times the sine squared theta. For tangent of 2 theta, there is a formula, but if you remember that tangent is sine divided by cosine, then it's easier to find the tangent of 2 theta by doing the sine of 2 theta times the cosine of 2 theta. So we're only going to do one problem, but the one problem we're going to do 4 different things. If the cosine of theta is equal to negative 2/3 and theta is in quadrant 2, find the sine of 2 theta, cosine of 2 theta, tangent of 2 theta, and the sine of 4 theta. Well, first, I'm going to draw the picture of that triangle. So it's in quadrant 2, so there's my terminal ray. There's my perpendicular, so here's my triangle. This is theta. Cosine is adjacent over hypotenuse. So the adjacent side is negative 2. The hypotenuse is 3. I'm going to find out what the side opposite is by using the Pythagorean theorem. I'm going to call that y because it's the side that's perpendicular to the y-axis. So x squared plus y squared is equal to r squared. And we're going to find out that y is the square root of 5. Okay, so now, in order to find the sine of 2 theta, which is 2 times the sine of theta times the cosine of theta, I'm just going to do 2 times the sine of theta. Now from this triangle is the square root of 3 over 5, square root of 5 over 3, sorry. And the cosine we already knew was negative 2 over 3. All I have to do is multiply those fractions together. I get negative 4 square root of 5 on top and 9 on the bottom. And it can't be reduced, so that's the answer. Now we're going to do this again for the cosine of 2 theta. How do I know which formula to use? Well, since they gave me in the original problem that cosine was negative 2/3, and because it doesn't have a radical in it, I'm going to use 2 cosine squared theta minus 1. You can use the other one. It's just that it's a little bit nicer math using this particular formula. So, order of operations, first you square and get 4/9. Then you multiply by 2 and you get 8/9. And 8/9 minus 9/9 is negative 1/9. So the cosine of 2 theta is negative 1/9. For tangent, instead of using that obnoxious formula they gave us, I'm just going to do the sine of 2 theta over the cosine of 2 theta. Because I know the sine of 2 theta is 4 the square root of 5 over 9. And I know the cosine of 2 theta is negative 1/9. And those 9s are going to cancel. You end up with positive 4 the square root of 5. The last thing that we're going to do is the sine of 4 theta. To do the sine of 4 theta, we're going to rewrite this as the sine of 2 times 2 theta. So it looks like the double angle formula. Well, it is, because what I'm going to do is 2 times the sine of 2 theta times the cosine of 2 theta. The sine of 2 theta we said was negative 4 square root of 5 over 9, and the cosine of 2 theta was negative 1/9. And I'm going to multiply those fractions together, and I get positive 8 the square root of 5 over 81. And that's all we need to do from section 7.3.